The first method of factoring that we are going to look at is factoring by the greatest common factor. The greatest common factor is the highest number that divides exactly into two or more numbers. When you are factoring by the greatest common factor, the trick is to see what can be factored out of every term in the expression. You don't want to make the mistake of thinking that factoring means dividing. You are not dividing something off and making it magically disappear. Remember that factoring means dividing out and putting in front of the parentheses. Nothing disappears when you factor. You are simply rearranging the terms. For the first example, we are factoring the polynomial 4x plus 4. Hopefully everyone can see that the common factor in this example would only be 4. When we factor out of 4, we want to write what's left over in the polynomial. In the parentheses, we will have x plus 1. This 1 right here must be there. A common mistake is to write 0 because you think you're taking the whole part out, but remember, 1 is a placeholder. It's holding its place for 4. If we were to multiply this back out, we want to make sure this equals the same thing. We distribute the 4 to both terms in the parentheses, and we end up with 4x plus 4, which is the same thing we started with, and that's what we want. For our next example, we have the polynomial negative x to the fifth plus 9x to the third. As you can see in the note above, in the gray box above, I said if the leading coefficient is a negative, you must factor the negative out with a GCF. In this case, this expression is the same as negative 1 times x to the fifth plus 9x to the third. Our leading coefficient is negative 1, and therefore we need to make sure that comes out with the GCF. Looking at the coefficients, we have negative 1 and 9. There are no common factors between negative 1 and 9, so now let's look at our variables. In the first term, we have x to the fifth. In the second term, we have x to the third. We can remove 3 x's from both terms, so our common factor, without forgetting the negative, will be negative x to the third. When we factor that out, the first term will remain as x squared. The second term will become negative 9. Alright, the reason why it's negative 9 is because 2 negatives makes a positive, and we do want a positive in our final answer. Before we move on to the next one, let's double check our work, make sure everything is good. We are going to want to distribute our common factor back into the parentheses. Negative x to the third times x squared leaves you with negative x to the fifth. Negative x to the third times negative 9 leaves you with positive 9 to the third. 9x to the third. Sorry about that. And yes, that is the same. So therefore, the expression we factored is correct. Moving on, let's look at number 3. Alright, the polynomial given to us in number 3 is 5x to the third plus 25x squared plus 45x. First, we want to look at the coefficients. We have 5, 25, and 45. I notice right away that there's a common factor of 5 between all of those terms. So I know part of my GCF will be 5. Now I'm going to look at the variables. In the first term, I have x to the third. In the second term, x squared, and third term, x. Because every term has at least one x, I know that x will be part of my common factor. I now have my GCF, so I can factor 5x out and in parentheses I am left with x squared plus 5x plus 9. And before I move on, I just want to double check my work. 5x times x squared leaves you with 5x to the third. 5x times 5x leaves you with positive 25x squared. And 5x times 9 leaves you with positive 45x. Quickly check over what you have. Looks the same, so we did our work correctly. And our original factored expression is correct. All right, last one. Go through this one kind of quickly. All right, this one looks a little bit different as far as the terms that are given to you. If we focus on our leading coefficients, we have a coefficient of 6 and a coefficient of 2. That means that our common factor between our coefficients will be positive 2. Remember, you only want to factor a negative when it's with the leading coefficient or the first term in your expression. All right, now that we know our common factor of the coefficients is 2, let's look at our variables. In the first term, we have x squared. In the second term, we have x. That means we do have a common factor of at least one x in each term, so we'll take out an x. And same goes for y. First term, we have 1y. Second term, we have 2. We can factor 1 out for our common factor. Now in parentheses, we are left with, if we factor 2 from 6, we are left with 3. We took 1x away, we are left with 1x. And we took the only y out, so that is it for the first term. The second term, we are removing a common factor of 2, so we factored the 2 out, we factored the only x out, and we are left with 1y. So our final answer is 2 times x times y multiplied by, in parentheses, 3x minus y. And you guys can check this one by yourselves.